Let's talk about Module 4, where we're working with lines and angles, um, mostly angle relationships. We get introduced to various angle relationships. First angle relationship that we deal with are complementary angles. When two angles are said to be complementary, it's because they have a sum of 90. They add up to 90 degrees together. When you add their angle measures in degrees, it adds up to 90 degrees. Supplementary angles are much more common. We'll be seeing those a lot more. Those add up to 180 degrees. So if two angles add up to 180 degrees, they are said to be supplementary. Notice here in the examples that they don't necessarily have to be adjacent or touching each other. Any two angles that when their sums add up to 180, they can be said to be supplementary. They don't necessarily have to be adjacent to each other. Speaking of adjacent, adjacent angles are angles that are next to each other. Okay, if they share a common vertex, if they meet at the same point, then they are adjacent. On your notes, take a look at the examples versus the non-examples. I like to specifically focus on the non-examples because that shows you why they're not whatever's being described. Vertical angles. When you have one intersection, okay, when two lines go through each other, vertical angles are across from each other. Across, so like here in the examples, angles AEB is vertical from angle DEC because they're across from each other at that intersection. A linear pair. A linear pair is basically the combination of angles being both adjacent and supplementary. If you're adjacent, if you have a common vertex and you add up to 180 degrees, then you're said to be a linear pair. Here's a word that we've seen before, perpendicular. Okay. First thing I want you to notice is the symbol for perpendicular, which is like an upside down T. Okay, that's the symbol to show that two lines are perpendicular. Perpendicular lines intersect, and some of the things that this graphic tells you is that when you have perpendicular lines, there's 1, 2, 3, 4 angles that are formed. Not only are one of the angles 90 degrees, all four of them are 90 degrees. Meaning all four angles are congruent. Here you also see the right angle symbol, which is it's like a little box. That means 90 degrees. And we finish up with something called the perpendicular bisector theorem, which just says that if you have a point on a perpendicular bisector, perpendicular means that meeting at 90 degrees. Bisector means cut in half. So if you are on a perpendicular bisector, then you are equidistant from the endpoints on that segment. So here in the graphic, P is located on a perpendicular bisector because P is located on line M, and line M is cutting segment AB in half. That's what these slashes mean. So if this is the original way the graphic looked, okay. If I were to measure the distance from P to A and P to B, I would find that that is also those distances are also congruent. That's perpendicular bisector theorem. Okay. Parallel lines. First of all, parallel lines, the symbol on a diagram you see up here are these arrows. When you see arrows, that's saying that the lines are parallel. Then on a statement, either two vertical lines like this, or sometimes in some books they'll make them look diagonal. But as opposed to the symbol for perpendicular, that's the symbol for parallel. So here in this graphic, line PQ is parallel to line RS. So parallel lines lie on the same plane, and they head in the same direction, meaning that they never intersect. Okay. A transversal, which is the other line that's here, in this case line PR is a transversal, is a line that intersects a pair of parallel lines. It touches both parallel lines. So in this case, PR is a transversal. Skew lines, we don't see it too much, but just in case, are lines that never intersect, and they lie on different planes. So they just like parallel lines, they don't touch, but it isn't because they're going in the same direction necessarily. They're just because they're on different planes. Okay. Some more angle relationships. On the first slide, you saw already a few angle relationships. The difference here is that these angle relationships rely on there being three lines. Typically, two of the lines are going to be parallel. We'll get into that on the next slide. But you have two lines and then a transversal that intersects both of them, creating now 8 angles. You saw when we have just one intersection, there's 4 angles, but if we have 2 intersections, there's 8 angles. So some of these angle relationships, we have exterior angles, which are angles on the outside. Now, when we say exterior, we're talking about the lines that are typically going to be headed in the same directions. I know in this graphic there aren't any parallel lines, but we're talking about what's outside of that. So in this case, it would be angles 1, 2, and 7 and 8. Those are the exterior angles in this diagram. Interior angles would be inside of those lines. So on the interior angles here are 4, 3, 5, and 6. Consecutive interior, your book calls it same side interior. I've seen several books that call it same side interior, and there what we're talking about is on the same side of the transversal. So consecutive interior has to be inside. So we already said that the inside angles were 4, 3, 5, and 6, but now if they're going to be on the same side of the transversal, specifically those pairs would be 4 and 5 because they're on the same side of the transversal. Those are consecutive interior, and also 3 and 6. If we skip here, just so that we can stay on the inside, if we skip to alternate interior, we still have to be on the inside of the two lines of, in this case, Q and R, but now on alternate sides of the transversal, it would be 4 and 6, and then 3 and 5. Alternate exterior angles are still on alternate sides of the transversal, but now on the outside of the lines that are typically going to be parallel. So like here, 1 and 7 would be alternate exterior. So would 2 and 8. Those are also alternate exterior. Lastly, corresponding angles. The best way I could describe corresponding angles are they are in the same location in their respective intersection. So like here, 1 and 5 are both in the top left. those are corresponding. 2 and 6 are both in the top right, those are corresponding. 3 and 7 are in the bottom right, those are corresponding. 4 and 8, those are corresponding. So these just establish the names of the angle relationships. But these relationships don't mean much until two of those lines become parallel, which they're about to. So here in the notes, I wrote down what I've just described to you, so you can go over that at your own leisure. Everything that's on here in writing, I just verbally described to you. So here we go. If two of those lines were to be parallel and the third line were the transversal, now these relationships mean something. So corresponding angles. If you determine that two angles are corresponding and the two of the lines are parallel, now we can say that those angles are congruent. So, in this particular diagram, angle 1 is congruent to 5, 2 is congruent to 6, 3 is congruent to 7, 4 is congruent to 8 because they're corresponding. Here in this next diagram, alternate interior, okay, consecutive interior and alternate exterior. Anytime you see the word alternate, which remember refers to the transversal, okay, anything with alternate, whether your interior or exterior, those are going to be congruent. They're going to be the same. So we already talked about how to identify alternate interior and alternate exterior, but now if the two lines are parallel, we know that they're going to be congruent. Consecutive interior, which here I even have it written the way your book does, which is same side interior, those are going to be supplementary, which we learned on the first slide means that they add up to 180 degrees. And this last theorem here is perpendicular transversal theorem. Just says that if you have 3 lines and the transversal is perpendicular to one of them, it has to be perpendicular to both. In this case, what would happen is all 8 angles would be 90 degrees. And on this last slide, I just decided to throw in some review. You've seen this before. We're going to start dealing with, not only did you see it earlier this year, but you saw it in Algebra 1, where now we see a parallel perpendicular, but we talk about the equations of parallel and perpendicular lines. So quick review. On a coordinate plane, 2 lines that are parallel have the same slope. On a coordinate plane, 2 lines that are perpendicular have negative reciprocal slopes. Negative reciprocal means, the word negative means that the 2 signs have to be different. Reciprocal means that since slope is a fraction, it's a ratio, it's rise over run, one is the flipped version of the other one. The rise of one line has to be the run of the other one and vice versa. And then any lines that just have different slopes, those are just going to intersect. It's nothing special. They're not going to be parallel. They're not going to be perpendicular. They're just going to, as long as they're on the same plane, they're going to intersect one time.